All right, today we're going to talk about conics in standard form. We're going to start with a little bit of a warm-up, just going over one of each type of conic and how to graph it and how to identify all the key information out of it. So this first one is going to be a hyperbola because we have an x squared that's positive and a y squared that's negative. So that's my first answer here, is that it's a hyperbola. Since x squared is positive, this is going to open right-left. And the transverse axis will be the y equals of the point that goes through the center. So y equals 4. The conjugate axis will be the vertical line, x equals the point that goes through the center, so x equals 1. And the center here is the point 1, 4. A squared is always underneath the positive term, so a is 6. And b squared is underneath the negative term, so b is 1. Next, they want c. Well, c squared for a hyperbola is a squared plus b squared, so 36 plus 1. So c is the square root of 37. That means, actually, before I get the vertices, let's go ahead and start graphing. We're going to have right by 1, up by 4 for our center. For our vertices, we'll go, we're going to go left-right because this opens left-right. So we're going to go right by 6, and we're going to go left by 6, so that gives us vertices of negative 5, 1 and 7, 1. The co-vertices will go up by 1 and down by 1, so that gives us co-vertices of 1, 5 and 1, 3. I'm going to go ahead and draw in my rectangle. You guys know what comes next. I'm going to draw my slant asymptotes. So here and here, and then I'm going to place in my foci. The foci are going to be left and right of the vertex, so I start with 1 and I'm going to subtract out rad 37, y value is 4, and then I'll start at 1 and I'll add the square root of 37 and the y value is 4. So I'll be just here and just here for my foci. And then to graph the hyperbola, I start at my vertices and I hug my slant asymptotes. Then the last thing I have to do is come up with the equation for the asymptotes, and that's going to be a rise over run situation. So plus 1 divided by 6, so I have y minus the y value of the center, which is 4, equals slopes of plus or minus 1 over 6 times x minus the x value of the center. So that's a practice hyperbola problem. The next one is going to be a parabola because I only have one variable squared. So my type of conic is the parabola. This opens up down because x is squared, and the negative here tells us it opens down. The line of symmetry will be the vertical line that goes through the vertex, which is x equals 2. The vertex is going to be at the point 2, 3. And remember that this value here, negative 4, equals 4p, so our p value is negative 1. So if I plot in my vertex at the point 2, 3, I need to go down by 1 to get to my vertex, so that'll be the point 2, 2. And then I go up in the opposite direction by 1 to get my directrix, which will be y equals 4. And then the points on the lattice rectum, remember that the lattice rectum is this value wide. So I start at my focus and I go left by 2 and right by 2. And that enables me to graph my parabola and tells me that the points on the lattice rectum are the point 0, 2 and the point 4, 2. So next let's do an ellipse. This one is an ellipse because we have both terms squared and both terms positive. I always like to start with the center here. That's going to be 3, negative 1. Since our bigger number is under y, this is going to be a vertically oriented ellipse. So the major axis is going to be vertical, and it's going to be through the x value of the center, so x equals 3. The minor axis will be horizontal, and it will go through y equals negative 1. A squared is always the bigger denominator, so a is 5. B squared is the smaller denominator, so b is 2. And then for an ellipse, c squared equals a squared minus b squared. Remember, when we have a plus here, We have a minus here. So I have c squared equals 25 minus 4. So c is going to be the square root of 21. Let's go ahead and start graphing. I need the point 3, negative 1 for my center. I'm going to go up by 5 and down by 5 to get to the vertices. So the vertices are at 3, 4, and at 3, negative 6. The co-vertices are going to go left by 2 and right by 2. So they're going to be at 1, negative 1, and 5, negative 1. And I can go ahead and sketch my ellipse now. I do need the foci. The foci are going to start with the center. So I have the x value is 3, and then I have negative 1. I'm going to add rad 21 to it. And I'll have 3 and then negative 1 minus rad 21. Rad 21 is about 4.5. So I think my foci kind of sit here and here. Okay, last but not least, we are going to look at a circle. And I know that this is a circle because x and y are squared. And when I put it in standard form by dividing by 9, I'll have the same denominator. So I have a circle. My center is going to be the point 1, negative 2, which is the same thing as the focus in the circle. The radius is 3. The vertex form of the equation, all I have to do is divide by 9 all the way through. And there I am. So when I graph this, I put in the point 1, negative 2 for the center, and then I go up, right, down, and left all by 3, and I sketch in my circle. Now, the next part of the lesson, once we've reviewed our conics, is to learn how to convert to vertex form when we're given a different form. So I want to get this guy, which is a standard form of a parabola, into vertex form. Well, I'm going to do that by completing the square. First thing I'll do is subtract 2 from both sides. Then I'm left with x squared minus 6x. And to complete the square, I need to take this negative 6 value, I need to divide it by 2, and I need to square it. That's going to give me 9. I'm going to have to add 9 to both sides, though, to maintain equality. So I end up with an equation that says y plus 7 equals x minus 3 squared. And if I put parentheses around this, and I have a 1 here, this is really in x squared equals 4py form, and I could go ahead and graph it. So that's what we're going to be working on, is completing the square to get our conics in standard or vertex form, I should say, from standard form to vertex form. So first thing we want to do is identify the type of conic. Here I have both squared, x and y squared, and 2 different coefficients. Both are positive. So this is going to end up being an ellipse. If one were negative, it would be a hyperbola, or if the coefficients were the same, it would be a circle. So to put this in vertex form, I first take my x values, and I write them together, I group them. Then I take my y values, and when I take my y values, I have to factor out the coefficient in front of y squared. So I have to do that for both y values. I had to take 4 out of both 4 and negative 8. Then I'm going to throw the constant of negative 9, or the constant of 9, over onto the right by subtraction. Now I'm going to add here a 9, which is 6 over 2 squared. When I added 9 on the left, I have to add 9 on the right. In here, I have to take negative 2 over 2, which is negative 1, and square it. But when I added a 1 here, I really added a 1 times the 4. So that's 4. I have to add 4 to the right as well. So now I can go ahead and write it with perfect squares, which is really nice. And I'm getting somewhere. And on the right, negative 9 plus 9 cancel, and I have a 4. To completely get it to vertex form, I now have to divide by 4 to force this to be a 1 on the right. So I have x plus 3 all squared over 4 plus y minus 1 all squared equals 1. So I can go ahead and graph this ellipse. It's got a center of negative 3, 1. Vertices go left, right by 2. Because of that, 4 is a squared. b squared is 1, so my co-vertices are up and down by 1, and I can just sketch in my ellipse right there. Okay, let's do another one. This time, x and y are both squared, but one of them is negative. Therefore, this is going to be a hyperbola. I do the same process of completing the square. This time I have a coefficient in front of x squared that I have to cancel out. So that negative 4 has to come out of the negative 4 and out of the 24. So that gives us x squared minus 6x. I'll group together the y squareds as well. Then I'm going to add 41 to both sides in order to move the coefficient over. Next, I'm going to take this negative 6, divide it by 2 to get negative 3, square it to put a 9 in. I really put in 9 times negative 4, so I'm subtracting by 36 on both sides. Here I have a 4 divided by 2 is 2, squared is 4, so now I'm adding 4 to both sides. Let's go ahead and rewrite this. Negative 4 times x minus 3 all squared, plus y plus 2 all squared. 41 minus 36 is 5, plus 4 is 9. And now I need to go ahead and divide both sides, or all the terms, by 9. So that's going to give me negative 4 over x minus 3 squared over 9, plus y plus 2 squared over 9 equals 1. And I'm not quite done putting it in vertex form. I really need to bring this negative 4 underneath here. So when I rewrite this, I'm going to have, first I'll put the positive term first, y plus 2 all squared over 9. Then we'll subtract x minus 3 squared, and then it's going to be divided by 9/4. And I know that looks funny, but it's going to help me because this 9/4 is b squared. So it's going to help me graph this. This is my vertex form that I'm going to use to graph it. So to graph it, I'm first going to put in the center, right by 3, down by 2. Then I need to, I'm opening up, down because my y squared is positive. So I need to go up, down by 3 to get to the vertices. My b squared is 9/4, so my b is 3/2. So I go left and right by 1.5. Then I can actually put in my rectangle here. I can sketch my slant asymptotes. I have my vertices are here and here. And then my foci I can plot in. I'm actually not going to worry about that now. My focus, haha, play on words. My goal here is to get you guys to complete the square, and I'm just throwing the graph in to show you what it looks like. Okay, next we have one last one, and this one is going to be a parabola that we are finding by completing the square. So the nice thing here is on the left, this is already in a form that I can factor. It's already written so that I can say x minus 1 all squared. Yay. And then on the right, I just need to factor out a negative 4. So I get negative 4 times y minus 1. This is our vertex form. By the way, I knew it was a parabola because x is squared and y is not squared. So this guy, when I graph it, will have a center or a vertex of 1, 1. My negative 4 equals 4p, so p is negative 1. My focus is here. My lattice rectum will be 4 across, so I go left 2 and right 2. I can open up my parabola facing down because of the negative sign in front of the y, and my directrix will be right here at y equals 2.